Greetings, mathematicians. Mrs. Hall here. Welcome back to May number corner, the water evaporation experiment lesson 2. Unfortunately, I'm not going to be able to do my British accent for the whole lesson because I have seasonal allergies and my nose is a little stuffy. Okay, let's continue back into my regular place. Hi, it's me. Today we're on day 6, and in your Google Classrooms, you've each had a document to record your observations. So far, just a review, we have been making observations for 6 days. So your top part of your document should look like this. Let's quickly jot down our observations for day 6. Notice that the water level is now at 160 mLs, which means that if we started at 200 mLs, 40 milliliters have evaporated. That means that the water has left its liquid state and turned into a gas and gone off into the air. So 40 milliliters have evaporated, and we're currently at 160 milliliters on day 6. So as you can see, I've been updating my water evaporation chart, and notice that I made observations on day 0, 1, 2, and 3. Oh, but I forgot on days 4 and 5, and now I'm back in day 6 recording my numbers. But not to worry if I didn't do it every day, and you'll see why. Time to synthesize our data. And I know that last week we did a lot of work with line plots. Today we are going to make a line graph to measure change over time. If possible, and you have a printer, try to pause the video now and print out the water evaporation graph PDF that's posted on your Google Classrooms. And if not, no worries, just watch me follow along. You'll get a lot out of the lesson. Here we go. This is myself up here. This is our water evaporation graph, and it's time to start plotting our data. You'll notice that this is day 0, and here is my y-axis, which is labeled milliliters of water in container. And on the x-axis, you'll notice that it says number of days that have passed. I lined my red dot right on the line at day 0, and I matched it with 200 milliliters because that's what we started with. So could all of you please make your first plot in the same place? If not, just follow along. For day 1, I made my next plot at 190 milliliters. I also made sure to line that up with day 1 on the bottom. For my third plot, which is day 2, I did the same thing. I had 180 milliliters and we were on day 2, so I made sure that my plot was at the intersection of 180 and day 2. All right, ready for day 3? Day 3, oh, this is kind of crazy. Because I had only 176 milliliters, I couldn't put it on the exact intersection. So what I had to do is I first said 176 is just a little bit less than 180. So I made my dot just underneath the 180 benchmark line. And I also lined day 3 because that's the day of data that we are recording. Now for day 6. Interesting. Day 6 came back at 160 milliliters. So I made sure to put my dot at 160 milliliters, but I had to skip days 4 and days 5 because I didn't make observations on that day. So that's one detail you need to make sure you're doing when you plot your line graph. And here I am. I've lined my dot with day 6 at 160 milliliters. This is the most fun. It's time to connect my data. So what I did, and what you can do at home, is I drew my lines, sort of like playing connect the dots, through my 5 data points. And it's so funny, I noticed something. Even though I didn't make observations on days 4 and 5, connecting the dots, I can get an idea of what happened on those days. So, for example, even though I didn't take data measurements on days 4 and 5, well, it looks like on day 4, I got down to about 170. And on day 5, I was around 165 mLs. Now, let's just take a moment to soak up all the information that's happening on this beautiful line graph. And now I'd like you to answer the following questions below. You could post all your answers on the Padlet, which I know you are all wonderful about. My first question to all of you is, what's happened to the water since we started the experiment? My second question is, how do the results so far match those predictions you made last week? My third question is, what can you say about the rate at which the water is evaporating? How much water has evaporated each day? Is it the same or different amount? Finally, if the amount that has evaporated each day is different, are the differences large or small? All right, have fun, mathematicians. Cheerio!